ground, while if you try the same for a ball made out of clay, it will not. What is the physics behind this phenomenon? Let us try to find out. The very mention of the word collision generally springs up an image of two speeding vehicles hitting each other with an impact. Interestingly, while collision for a layman suggests an automotive disaster, in the domain of physics, collision refers to a wide range of events, from the atomic scales up to the galactic scales. Let us examine collisions and learn about their classification. A collision is defined as an isolated event in which interacting bodies exert forces on each other for a very short interval of time. During a collision, they may be in contact or not in contact, wherein they merely influence each other's path. Whenever objects interact, as in collisions, total momentum before collision is the vector sum of the momenta of each of the objects in the system before collision. After collision, the total momentum of the system equals the total momentum before collision, provided the system is isolated. Hence, total momentum of the system is conserved. In addition, by the law of conservation of energy, total energy is also conserved. However, kinetic energy of the system is not always conserved. Based on whether kinetic energy is conserved or not during the collision, we have two types of collisions: elastic and inelastic collisions. To have an insight into the concept, let us perform an experiment using an apparatus called an air track. To begin with, take a glider 1, and attach a rubber band bumper in front of it. Similarly, to the glider 2, attach a flat metal plate in front of it. Turn on the air supply and launch the gliders from the opposite ends of the air track with initial velocities u1 and u2 respectively. Note down their velocities after the collision as v1 and v2 respectively. Observe that the total kinetic energy before collision is equal to the total kinetic energy after the collision. Clearly, this indicates that the kinetic energy is conserved. This type of collision, in which kinetic energy of the system is conserved, is termed as an elastic collision. Repeat the experiment by inserting a wax cup attachment to glider 1 and a pin attachment to glider 2. Note down the velocities of the gliders before collision. Also note the common velocity v of the gliders with which they move after the collision. Observe that this time the total kinetic energy of the system before collision is not equal to that after collision. Clearly, kinetic energy is not conserved. This type of collision, in which the kinetic energy of the system is not conserved, is termed as inelastic collision. In fact, an inelastic collision is always accompanied by a loss of kinetic energy. This happens as during the collision process, a part of the kinetic energy gets converted into other forms of energy, such as heat, sound, deformation, etc. Remember that in reality, all collisions are accompanied by some loss in kinetic energy and hence are inelastic in nature. However, collisions at the atomic level can be perfectly elastic. Note that in case of inelastic collisions, after the collision, just as in our experiment, it is termed as a perfectly inelastic collision. Reverting to the conservation laws, we recall that momentum is a vector quantity. Hence, it must be conserved along different directions independently. This leads to the further classification of collision in one dimension, and collision in two dimensions. To summarize, collision is defined as an isolated event in which interacting bodies exert forces on each other for a very short interval of time. Momentum and total energy are always conserved in a collision, but kinetic energy may or may not be conserved. The type of collision in which kinetic energy is conserved is termed as elastic collision. The type of collision in which kinetic energy is not conserved after collision is termed as inelastic collision. We have now developed a good understanding of collisions in one dimension. Stay tuned to find out how we deal with collisions in two dimensions.